Picture a world encased in a gleaming sheet of ice, its surface a cosmic mirror reflecting the distant sunlight. This celestial orb, barely larger than Earth's moon, holds a secret beneath its frozen exterior. As we zoom in, the smooth icy plains come into focus, crisscrossed by mysterious reddish lines that hint at the dynamic forces at work beneath. Beneath this icy armor lies a vast ocean, its waters in constant motion, warmed by invisible forces and shielded from the vacuum of space. This liquid realm, possibly containing more water than all of Earth's oceans combined, remains hidden from our direct view, protected by miles of solid ice. This isn't a scene from a science fiction novel or a CGI creation for a blockbuster movie. It's a real place, orbiting the largest planet in our solar system, waiting to be explored. Welcome to Europa, one of Jupiter's Galilean moons, a world that holds secrets that could revolutionize our understanding of life in the universe. What if I told you that at this very moment, just a stone's throw away from Jupiter in cosmic terms, there exists a world with more water than all of Earth's oceans combined? A world where, as we speak, alien waves might be lapping against shores we've never seen, hidden beneath a crust of ice? Imagine standing on Europa's surface, the immense form of Jupiter looming in the sky, its bands and swirls clearly visible. Beneath your feet, through miles of ice, an ocean deeper than any on Earth churns with possibility. What life forms might call these dark waters home? What strange ecosystems might thrive in the depths, powered by energy sources entirely different from those we know on Earth? Europa isn't just another moon. It's possibly the most promising location in our solar system to find life beyond Earth. Its combination of liquid water, energy from tidal heating, and organic compounds makes it a prime candidate in our search for extraterrestrial life. As we embark on this journey to explore Europa, we're not just learning about a distant moon. We're potentially uncovering clues about our own origins and answering one of humanity's most profound questions. Are we alone in the universe? If this glimpse into Europa's hidden ocean has ignited your curiosity about the cosmos, don't let your journey end here. Like this video to let us know you're as excited about space exploration as we are. And make sure to subscribe to Exploring the Universe channel for more mind-bending adventures through our solar system and beyond. Together, let's dive into the mysteries awaiting us in the depths of the cosmos. Remember, every like, comment, and subscription helps us continue bringing these cosmic wonders to your screen. So join our community of space enthusiasts, and let's explore the universe together. Europa's surface is a mesmerizing spectacle, unlike anything we've seen in our solar system. From a distance, this Jovian moon appears as a smooth white yellowish orb, reflecting more sunlight than any other moon in Jupiter's retinue. As we zoom in, the true nature of its enigmatic surface begins to reveal itself. The first thing that catches the eye is the incredible smoothness of Europa's icy shell. Unlike our pockmarked moon or the cratered surfaces of many other celestial bodies, Europa's surface is remarkably flat. This smoothness suggests a young and active surface, constantly renewing itself and erasing the scars of impact craters. Perhaps the most intriguing features of Europa's surface are the reddish-brown lines crisscrossing the icy plains. These lines, ranging from a few kilometers to thousands of kilometers in length, form an intricate network across the moon's face. Scientists believe these lines are cracks in the ice shell, possibly areas where the ice is refrozen after being pulled apart by Jupiter's immense tidal forces. The reddish-brown color of these lines is thought to be caused by salts and organic compounds from the underlying ocean, pushed up through the cracks and exposed to Jupiter's intense radiation. This coloration provides tantalizing hints about the chemical composition of Europa's hidden ocean. The discovery that Europa's surface was made of water ice came through a combination of observations and deductions. Spectroscopic analysis from Earth-based telescopes and spacecraft like Voyager and Galileo revealed absorption features characteristic of water ice. The extremely high albedo, reflectivity, of the surface also pointed to ice as the primary component. Moreover, the density of Europa, calculated from its size and mass, suggested a composition of mostly water with a rocky core. The smooth, crackled surface further supported the idea of a solid but malleable material like ice, capable of flowing and reforming over geological timescales. While Europa's icy surface is fascinating, it's what lies beneath that truly captures the imagination of scientists and space enthusiasts alike. The existence of a subsurface ocean on Europa is one of the most exciting discoveries in planetary science. Evidence for this hidden ocean comes from multiple sources. One of the most compelling is Europa's induced magnetic field, detected by NASA's Galileo spacecraft. This magnetic signature is best explained by a layer of electrically conductive fluid beneath the surface, most likely a salty ocean. Another piece of evidence comes from the study of Europa's surface features. The cracks and ridges observed suggest a layer of ice floating on a fluid layer, allowing for movement and deformation of the surface. Estimates of the volume of water in Europa's ocean are staggering. While the exact depth is unknown, scientists believe the ocean could be 60 to 150 kilometers deep, covering the entire moon. If these estimates are correct, Europa could contain 2 to 3 times the volume of all Earth's oceans combined, despite being a much smaller world. The chemical composition of this alien ocean is a subject of intense speculation and study. Based on the reddish material seen on the surface and our understanding of the moon's formation, scientists believe Europa's ocean is likely rich in salts, particularly magnesium sulfate, Epsom salt, and sodium chloride, table salt. More intriguingly, the ocean might contain a variety of organic compounds. The interaction between the rocky core and the ocean could result in a chemically rich environment, potentially similar to Earth's deep-sea hydrothermal vents. This chemical diversity, combined with the energy from tidal heating, creates conditions that could potentially support life. The study of Europa's hidden ocean isn't just about understanding one moon. It's about expanding our concept of habitable environments and the potential for life in the cosmos. As we continue to explore and learn more about this intriguing world, we may be edging closer to answering one of humanity's most profound questions. Are we alone in the universe? At the heart of Europa's fascinating characteristics lies a powerful force that shapes this icy world: Jupiter's immense gravitational pull. This force, manifesting as tidal forces, is the key to understanding why Europa, despite its distance from the Sun, harbors a liquid ocean beneath its icy crust. Tidal forces, in simple terms, are the result of differential gravitational pull on an object. Imagine Europa as a rubber ball. Jupiter's gravity pulls more strongly on the side of Europa facing it than on the far side. This difference in gravitational attraction stretches Europa, much like how you might stretch a rubber band. To visualize this effect, let's draw a comparison with a more familiar scenario: the Moon's effect on Earth. The Moon's gravitational pull causes our oceans to bulge outward on the side facing the Moon and on the opposite side. This results in the high and low tides we observe on Earth's coasts. However, the tidal forces Europa experiences are far more intense. Jupiter is enormously massive compared to Earth's moon, and Europa orbits much closer to Jupiter than our moon does to Earth. As a result, the tidal forces on Europa are much stronger. Now, here's where it gets interesting. Europa's orbit around Jupiter is slightly elliptical, not perfectly circular. This means that as Europa orbits Jupiter, its distance from the gas giant varies slightly. When Europa is closer to Jupiter, it experiences stronger tidal forces and stretches more. When it's farther, the tidal forces weaken, and Europa relaxes slightly. This constant stretching and relaxing as Europa orbits Jupiter generates an enormous amount of frictional heating in Europa's interior. It's this heat that keeps Europa's subsurface ocean from freezing solid, despite the frigid temperatures of outer space. The tidal heating is so effective that it's estimated to generate about 1,000 times more heat in Europa than all of its radioactive decay. This makes tidal heating the primary heat source for Europa, unlike Earth where radioactive decay in the core is the main internal heat source. Europa's story becomes even more fascinating when we consider its relationship with Jupiter's other moons, particularly Io and Ganymede. These three moons engage in what astronomers call an orbital resonance, a sort of cosmic dance that enhances the tidal heating effect. Io, Europa, and Ganymede orbit Jupiter in a 4:2:1 resonance. This means that for every 4 orbits Io completes around Jupiter, Europa completes 2, and Ganymede completes 1. This isn't just a cosmic coincidence. It's a gravitational relationship that has profound effects on these moons. This orbital resonance amplifies the tidal forces experienced by these moons, particularly for Io and Europa. As they orbit, they regularly line up in the same positions relative to each other in Jupiter. This periodic alignment causes additional gravitational tugs, further intensifying the tidal flexing. For Europa, this resonance is crucial. It helps maintain the Moon's slightly elliptical orbit, preventing it from circularizing over time. If Europa's orbit were to become perfectly circular, the tidal flexing would decrease significantly, potentially allowing its subsurface ocean to freeze. The effects of this cosmic dance are most dramatic on Io, Jupiter's innermost large moon. Io experiences such intense tidal heating that it's the most volcanically active body in our solar system, with hundreds of constantly erupting volcanoes on its surface. While we're focusing on Europa, It's worth briefly mentioning the other Galilean moons of Jupiter. In addition to Io, Europa, and Ganymede, there's also Callisto. These 4 large moons, discovered by Galileo Galilei in 1610, each have unique characteristics. Io, volcanically active, covered in sulfur compounds. Europa, icy surface, subsurface ocean. Ganymede, largest moon in the solar system, with its own magnetic field. Callisto, heavily cratered surface, possibly with a subsurface ocean. Each of these moons provides a fascinating study in how a planet's gravitational influence can create wildly different worlds orbiting the same planet. However, it's Europa, with its combination of liquid water, energy from tidal heating, and potential organic compounds, that holds perhaps the greatest promise for potential habitability beyond Earth in our solar system. When it comes to the search for extraterrestrial life, Europa stands out as one of the most tantalizing destinations in our solar system. But why is this icy moon considered so promising? To answer this, we need to consider the basic ingredients necessary for life as we know it and how Europa might provide them. Scientists generally agree that for life to exist, at least as we understand it, 3 key ingredients are necessary. Often called the universal solvent, water is crucial for the chemical reactions that sustain life. Life needs energy to maintain itself and grow. These carbon-based molecules form the building blocks of life. Europa potentially offers all 3 of these ingredients, making it a prime candidate in our search for extraterrestrial life. First, as we've discussed, Europa likely harbors a vast subsurface ocean of liquid water, possibly containing more water than all of Earth's oceans combined. This provides the first crucial ingredient for life. Second, the tidal forces exerted by Jupiter provide a consistent source of energy. This energy not only keeps the ocean liquid but could also drive chemical reactions necessary for life. Third, the reddish-brown streaks on Europa's surface suggest the presence of organic compounds. These could have been delivered by comets or asteroids, or potentially produced by interactions between the ocean and the rocky core. But the presence of these ingredients alone doesn't guarantee life. However, when we look at extreme environments on Earth where life thrives, we find striking similarities to the conditions we believe exist on Europa. Consider the deep-sea hydrothermal vents on Earth's ocean floors. These environments are completely dark, under immense pressure, and often extremely hot, yet they support rich ecosystems. The basis of these ecosystems is chemosynthetic bacteria, which derive energy from chemical reactions rather than sunlight. Similarly, life has been found thriving in subglacial lakes in Antarctica, such as Lake Vostok, which has been isolated from the surface for millions of years. These environments demonstrate that life can exist in cold, dark, high-pressure environments similar to what we might expect in Europa's subsurface ocean. So, what kind of life might exist on Europa if it's there? Given the extreme conditions, any life in Europa's ocean would likely be microbial. These could be organisms similar to the chemosynthetic bacteria found near Earth's hydrothermal vents, deriving energy from chemical reactions rather than sunlight. However, the potential for more complex life can't be ruled out entirely. Europa's ocean is believed to be much deeper than Earth's, providing a vast three-dimensional space for life to evolve. Some scientists have speculated about the possibility of more complex organisms, perhaps similar to jellyfish or squid, that could have evolved in this alien sea. It's important to note that while Europa is promising, we have no direct evidence of life there yet. The search for life on Europa is one of the most exciting frontiers in space exploration, driving missions like NASA's upcoming Europa Clipper, which aims to study the moon in unprecedented detail. The possibility of finding life on Europa, even microbial life, would be a profound discovery. It would suggest that life might be more common in the universe than we currently believe, reshaping our understanding of our place in the cosmos. If the idea of an alien ocean full of mysteries makes your imagination soar, don't forget to hit that like button. Your engagement helps us continue exploring these fascinating worlds with you. Are you ready to dive deeper into the cosmic ocean? Let us know in the comments what aspect of Europa intrigues you the most. And remember, every like is a step further in our journey through the cosmos. By showing your support, you're helping us bring more of these mind-bending space explorations to your screen. So, let's keep the curiosity flowing and the discoveries coming. Like, comment, and let's continue this cosmic adventure together. Europa has been a subject of fascination for astronomers and planetary scientists for decades, and several missions have provided us with valuable data about this intriguing moon. Our first close-up views of Europa came from NASA's Pioneer 10 and 11 missions in the early 1970s, but these flybys were too distant to reveal much detail. The real breakthrough came with the Voyager missions in 1979. Voyager 1 and 2 provided the first detailed images of Europa's icy surface, revealing the complex network of lines crisscrossing the Moon. The most comprehensive study of Europa to date was conducted by NASA's Galileo spacecraft, which orbited Jupiter from 1995 to 2003. Galileo provided high-resolution images of Europa's surface, detected its induced magnetic field, and collected data on the Moon's composition and structure. Looking to the future, the most exciting upcoming mission is NASA's Europa Clipper, scheduled to launch in October 2024. This ambitious mission will conduct multiple flybys of Europa, coming as close as 25 kilometers to the Moon's surface. The Europa Clipper mission has several key scientific objectives. Characterize the ice shell and any subsurface water, including their heterogeneity, ocean properties, and the nature of surface ice-ocean exchange. Understand the habitability of Europa's ocean through composition and chemistry. Understand the formation of surface features, including sites of recent or current activity, and identify and characterize candidate sites for future exploration. To achieve these objectives, Europa Clipper will carry a suite of 9 instruments, including cameras for high-resolution imaging, spectrometers to determine composition, ice-penetrating radar to look beneath the surface, and a magnetometer to measure the magnetic field and ocean salinity. The data from Europa Clipper could revolutionize our understanding of Europa and potentially provide crucial information about its habitability. It might even detect biosignatures if they're present in material ejected from the subsurface. While the potential rewards of exploring Europa are immense, the challenges are equally significant. One of the most formidable obstacles is Europa's thick ice shell. Estimates of its thickness range from a few kilometers to tens of kilometers. Drilling through this ice to reach the ocean below would be an unprecedented engineering challenge. The ice is likely to be extremely hard due to the frigid temperatures, and any drilling operation would need to be entirely autonomous due to the communication delay between Earth and Europa. Concepts for penetrating the ice include thermal drills that would slowly melt their way through, or even nuclear-powered cryobots that could generate enough heat to tunnel through the ice. However, these are still theoretical and would require significant technological advancements to become feasible. Another major challenge is the intense radiation environment around Jupiter. Europa orbits within Jupiter's powerful magnetic field, which traps and accelerates charged particles, creating radiation belts far more intense than Earth's Van Allen belts. This radiation can damage spacecraft electronics and could be lethal to any unprotected astronauts. The Europa Clipper mission is designed with this challenge in mind, using radiation-hardened electronics and a unique orbit that will limit its exposure to the most intense radiation. However, any future mission aiming to land on Europa or operate there for extended periods would need even more robust radiation protection. Despite these challenges, scientists and engineers are already conceptualizing future missions to explore Europa's ocean. One intriguing concept is a melt probe that would tunnel through the ice and then deploy a small submarine to explore the ocean. Another idea involves looking for areas where the ocean might periodically break through to the surface, potentially allowing a probe to access the ocean without needing to drill through the entire ice shell. NASA has also studied concepts for a Europa lander that could analyze the surface composition in detail and listen for sounds from the subsurface ocean. While such a mission isn't currently scheduled, the results from Europa Clipper could inform its design and objectives. The exploration of Europa represents one of the most exciting frontiers in space exploration. While the challenges are significant, the potential discoveries, including possibly finding evidence of extraterrestrial life, make it a compelling target for future missions. As our technology advances and our understanding of Europa grows, we move closer to the day when we might unlock the secrets hidden beneath its icy surface. The study of Europa has profoundly impacted our understanding of habitability in the universe, forcing us to expand our concepts of where life might exist and thrive. This icy moon has become a cornerstone in the field of astrobiology, reshaping our approach to the search for extraterrestrial life. Traditionally, the concept of a habitable zone around a star was defined as the region where liquid water could exist on a planet's surface. This Goldilocks zone was thought to be the primary area where we should look for life. However, Europa has compelled us to reconsider this narrow definition. Europa orbits far beyond what we would traditionally consider the habitable zone of our solar system. Its surface is a frigid -260 degrees Fahrenheit, yet it potentially harbors a vast, liquid ocean beneath its icy crust. This realization has led to the concept of subsurface habitability, where life could exist in oceans beneath the surfaces of icy worlds, sustained by energy sources other than direct sunlight. This expanded understanding of habitability has several important implications. If subsurface oceans can support life, the number of potentially habitable worlds in our galaxy and beyond could be much larger than previously thought. Icy moons and dwarf planets, once considered barren, are now seen as potential abodes for life. Europa demonstrates that tidal heating can provide a long-term energy source to maintain liquid water and potentially support life. This suggests that moons of gas giants, even those far from their stars, could be habitable. Europa shows that liquid water can exist far beyond the frost line in a planetary system, where volatile compounds like water typically freeze. This expands the regions where we might look for habitable conditions. The implications for the search for life on exoplanets are significant. While current technology mainly allows us to detect large, close-in exoplanets, Europa suggests that we should also consider the potential habitability of exomoons orbiting gas giants. Future telescopes and detection methods may need to be designed with the capability to detect such moons and assess their potential for subsurface oceans. Moreover, Europa's potential habitability underscores the importance of considering alternative biosignatures in our search for life. While we often focus on oxygen as a biosignature in exoplanet atmospheres, life in a subsurface ocean might produce different chemical signatures. This prompts us to broaden our search criteria and develop new methods for detecting signs of life. In the field of astrobiology, Europa holds a special place. It serves as a natural laboratory for studying the potential for life in subsurface oceans, an environment that may be common throughout the universe. Studying Europa can help us understand the long-term stability of subsurface oceans, the potential for water-rock interactions to produce the chemical ingredients for life, how life might adapt to high-pressure, low-light environments, the potential for transfer of materials between the subsurface and surface, which could leave detectable biosignatures. Furthermore, Europa challenges us to think creatively about life's potential forms and metabolisms. Life in Europa's ocean would need to adapt to total darkness, high pressure, and potentially unique chemical environments. Studying the extremophiles on Earth that thrive in analogous environments, like deep-sea hydrothermal vents, can inform our understanding of potential life on Europa. The importance of Europa in astrobiology extends beyond the Moon itself. It serves as a proxy for understanding other potentially habitable icy worlds in our solar system, such as Saturn's moons Enceladus and Titan, or Neptune's moon Triton. The techniques and technologies developed to study Europa could be applied to these other worlds as well. Europa has revolutionized our understanding of habitability. It has expanded our search for life beyond the traditional habitable zone, forced us to consider new environments where life might thrive, and spurred the development of new technologies and methodologies in the search for extraterrestrial life. As we continue to explore Europa and apply its lessons to our wider search for life in the universe, we may find that habitable worlds are more diverse and more common than we ever imagined. Europa stands as a testament to the potential for life's tenacity and adaptability, urging us to broaden our horizons in the quest to understand our place in the cosmos. As we conclude our journey through the hidden ocean of Europa, it's crucial to reflect on what the existence of this fascinating moon means for us as inhabitants of Earth and as curious beings in a vast cosmos. Europa stands as a testament to the incredible diversity and potential of our solar system. Just a few decades ago, the idea of a moon harboring a vast liquid ocean beneath its icy surface would have seemed like science fiction. Today, it's a scientific probability that challenges our preconceptions about where life might exist. The existence of Europa forces us to confront a profound possibility. We may not be alone in the universe. While we haven't found evidence of life on Europa yet, the mere presence of an environment that could potentially support life is groundbreaking. It suggests that the basic conditions for life as we know it might be more common in the universe than we once thought. This possibility has far-reaching implications. If life exists in Europa's subsurface ocean, it would likely have evolved independently from life on Earth. The discovery of a second genesis of life, even microbial life, within our own solar system would suggest that life might be a common occurrence throughout the universe. This would fundamentally alter our cosmic perspective and our understanding of our place in the universe. Moreover, the exploration of Europa challenges us to push the boundaries of our technological and scientific capabilities. The engineering feats required to explore its subsurface ocean are immense, but they drive innovation and expand our abilities as a spacefaring species. Each breakthrough in our quest to understand Europa not only teaches us about this distant moon but also provides us with new tools and knowledge that can be applied to challenges here on Earth. The study of Europa also underscores the importance of planetary protection and ethical space exploration. As we contemplate missions that might one day directly sample Europa's ocean, we must grapple with the responsibility of ensuring that we don't contaminate a potentially pristine ecosystem with terrestrial microbes. This challenges us to develop new clean room technologies and to think deeply about our role as explorers of the cosmos. Perhaps most profoundly, Europa changes how we view our own planet. The possibility of life thriving in the dark depths of an alien ocean reminds us of the tenacity and adaptability of life. It encourages us to appreciate the unique conditions that allow life to flourish on Earth and reinforces the importance of protecting our own planet's delicate ecosystems. As we continue to explore Europa and other worlds in our solar system, we're not just satisfying our curiosity, we're expanding our cosmic perspective. Each discovery challenges us to think bigger, to question our assumptions, and to imagine possibilities beyond our current understanding. The exploration of Europa is more than a scientific endeavor. It's a journey that has the potential to unite humanity in the pursuit of knowledge and understanding of our place in the universe. In essence, Europa represents hope. Hope that we are not alone in the cosmos, hope that life can thrive in the most unexpected places, and hope that there are still great discoveries waiting to be made. As we peer into the cosmic ocean, Europa beckons us to dive deeper, to explore further, and to never stop wondering about the mysteries that lie beyond our terrestrial shores. If this journey through Europa's hidden ocean has ignited your thirst for exploration, don't stop here. Subscribe to the Exploring the Universe channel to continue unraveling the wonders of our solar system and beyond. Together, let's dive into the mysteries awaiting us in the depths of the cosmos. By hitting that subscribe button, you're not just joining a community of space enthusiasts. You're embarking on a cosmic adventure. Each video is a new expedition, a chance to witness the marvels of our universe and ponder the profound questions they raise. Remember, every like, comment, and share helps us reach more curious minds like yours. Your engagement fuels our mission to bring the wonders of space exploration to screens around the world. So, let's keep the conversation going. Share your thoughts in the comments. What intrigues you most about Europa? What other cosmic mysteries would you like us to explore? And don't forget to ring that notification bell. You won't want to miss our upcoming videos on black holes, exoplanets, and the search for extraterrestrial intelligence. Who knows? The next video might just change how you see your place in the universe. So, are you ready to embark on the greatest adventure of all, exploring the universe? Subscribe now, and let's journey together into the unknown. The cosmos is calling, and the next discovery is just one click away.